In this video, I want to have a look at graphing the sums and differences of functions. So if we're giving two functions, f of x and g of x, we can sketch the sum where we add the two functions together, or the difference where we subtract one from the other. Now there is a little bit of language that we need to learn here. When we've got coordinates written as x, y, we actually call the y coordinate the ordinate. So that's the word we use when we're referring just to the y value that a function takes at a particular point. The x coordinate is actually called the abscissa. You don't need to know that, it's not in the course, but it's just there because if I'm telling you what the y coordinate is, I may as well tell you what the x coordinate is called as well. Here we've got some guidelines as to how we're going to go about these questions. These are going to make more sense after we've had a look at some examples, so we're just going to go through them quickly. Now the first one is the most straightforward. If we're trying to sketch the sum, which we're going to call s of x, of those two functions, then if we know the y values, if we know the ordinates at different points, then we can actually just add those values together to find out what the new value is going to be. Some more systematic approaches though, if one curve has a 0, then when we add them together, say f of x has a 0, then the new value is just going to be the ordinate of the other value, of the other function, at that point. If the curves meet at the same point, then the ordinate of our new function is going to be double the ordinate of either of those functions of whatever value it is where they meet. If the ordinates of f of x and g of x are opposites, so for example, one might be 4 and one might be -4, then they're going to cancel out. So the ordinate of our new function would be 0. Through the rest of that, but we're just going to start with that to have a look at our examples. Our first example asks us to sketch x plus 2 on x. So what I've done is I've got us a graph of the function x and the function 2 on x, and we're going to add the two of them together. So I'm going to start at these points here because they seem quite nice to me. At this point here, our functions intersect, which means that when we add them together, it's going to give us double that value. So that is sort of just under 1.5, I'd say. So we're probably going to end up at just under 3. So our new function is going to cut through here. And we can do the same thing down here. When we add two negative numbers, we're going to end up with a negative answer, and it's going to be double that value. So that will be down here as well. Okay, so we now have 2 points where our function is going to pass through. One other thing that I didn't talk about before is the domain of this new function is going to only include values that were in the domain of both functions before. So our function x, its domain is all real x. It can take every x value. But the 2 over x, this red function here, it doesn't exist. It's undefined at x equals 0. So there's an asymptote down here, which means that our new function, our sum, is also going to have an asymptote there. So if one function is undefined at a particular value, then our sum is going to be undefined there as well. Looking at what's happening around the rest of the graph, we have to think about the strength of the two functions in different points, or think about which function is dominant. So if we have a look at this section, so just to the left of this dot, where this red line is increasing and the green line is decreasing. Now, as we get closer up here, if we have a look at, say, the value at, say, 1/2 here, this value is getting smaller and smaller and smaller, and this one's getting larger and larger. So when we think about the significance of the y values at smaller and smaller x values, the red value is going to be more significant because the green value is getting closer to 0. So when we add a large number plus a smaller and smaller number, this one's hardly going to change our sum from what this original red value was. What that means is that our sum is going to approximate and get closer and closer to that red line the closer our x values get to 0. So what that means is that it's going to come up here and get closer and closer and closer to that y value. That's a bit wobbly at the end there. All right, if we think about what's happening to the right of the point we already know, again, we can think about the strength. So as we move over here, these red values, the values of the function x over 2 are getting smaller and smaller. They're getting closer and closer to 0, so they're becoming less and less significant. They're not changing our sum very much from what the value of the green function was. So in a similar way, this new function, our sum, is going to start to approximate our green function. So we're going to come up here and get closer and closer and closer. Oops, didn't mean to rub something out. Get closer and closer and closer to that green function there. Now the same thing's going to happen down the bottom here. So we're going to end up with a function that gets closer to the red one the further we get to 0, and closer to the green one as our x values get larger in the negative direction. In our graphing software, what that actually looks like, you can see that blue function there. And as we zoom out, you can see that it does approximate the green function and the red function over here as we get to our different values of x. Second example, we're going to look at the same two original functions, but this time we're going to find the difference. So we're finding x minus 2 over x. Difference questions, the easiest place to start is still these points of intersection. So if they have the same value and we're subtracting one from the other, that is going to be a 0 in our new function. So here and here we know that our new function, our difference, is going past through the x-axis. We also know that, again, we're going to have this asymptote down that y-axis at x equals 0 because that red function has an asymptote there as well. What's happening to the rest of the graph? We need to remember which order we're subtracting. So it's x minus 2 on x. So it's always going to be the green function minus the red one. So we can see that as we move further right on our graph, we're using a larger value for x, subtracting smaller and smaller values of 2 over x. So again, as we move to the right, our function is going to get closer and closer to that green function. All right, so we know it's going to start here, we know it's going to come down here, and then as we get closer to 0, we're going to end up with something really close to 0 minus a very large number. Now that's going to be almost the negative of this value. Okay, so if you take, say, 0.01 minus a huge number, it's going to be almost reflected down the bottom, just with that slight 0.01 difference. So we are going to end up with very large numbers down here. What that means is that our curve, our new function, is going to curve down this direction through our 0, and it's going to get closer and closer to that asymptote down here. Now you can think through it the same way, and we're going to end up with a very similar sketch here. So we're going to come up towards infinity, through that 0 there, and then get closer and, oops, hang on, that's not right. And then get closer and closer to our green curve as we come down here. All right. So that is what our difference looks like. The actual graph using our graphing software, you can see how it approaches the green function up here and our asymptote down the bottom. So that's a few examples of graphing sums and differences of functions.